The SSERVI Angioletta Coradini Mid-Career Award is given annually to a mid-career scientist for broad, lasting accomplishments related to SSERVI fields of interest. Angioletta Coradini, who I knew, was an Italian planetary scientist who inspired astronomers and planetary scientists around the world. Dr. Rivkin, who we all know as Andy, is a planetary astronomer and principal investigator in the space exploration sector at APL. Prior to that, he was a research scientist at MIT and a postdoc at the University of Arizona. He was the investigation lead for DART, and I want to make an aside that I told Andy we invited him to an event at the Italian embassy a few months back. I personally consider this up there with Apollo 11 in terms of missions that NASA has done. It's one of the most important missions that humanity has ever done. We showed that we could deflect an asteroid if a killer asteroid is heading our way. Is there anything more important than that, right? I mean, and I told him this, and he was the project scientist for that. So, I mean, for that alone, he should get enormous, enormous accolades. But he did so many other things. He was a collaborator on New Horizons. He's been associate member of the Dawn camera team, a science liaison for mission studies on the Planetary Decadal Survey, an associate member of the Deep Space One science team, PI for, we got to know each other because he was PI for SSERVI's Vortices team for quite a number of years. He served the community as treasurer for the DPS and a local and/or science organizing committee chair for DPS, NESF, and a number of conferences, too many to name right now. He was a steering group member for SBAG, a JWST asteroids focused group leader, and had asteroid 13743 Rivkin named after him in 2002. I can't think of anyone more deserving for this honor than Dr. Andy Rivkin, so please give him a hand. Andy, great to have you, and thanks for joining us.
Thanks for that wonderful introduction. Let me see if I can share these slides here. So thanks for having me. Thanks to the awards committee. Thanks to SSERVI, of course, to the meeting organizers. I want to give a special shout out to my current SSERVI PI, Jen Heldman, who's there. I am sorry I can't be there in person, as noted. Delta decided that it should be an extra 29 hours worth of travel for me, so that kind of put the kibosh on this trip. I'm very glad. I had Ben's reaction to his award being an old guy award. When I would tell people that I had won the mid-career award, everyone said, "Well, congratulations on being mid-career," so that's nice. I think a lot of the response to that might be because there have been a number of times over the years when after a talk or after a paper came out, people would go, "Ooh, Andy, I think your career's over." So to be considered mid-career is really nice. Another interesting point is that I'm given this, and another reason I wish I were there in person is because I try to feed off the audience. So if you're able to unmute the room so I can hear whether people are reacting or not, whether it's with cheers or boos, that would be awesome. I'd be happy to have you guys unmuted if that's possible. If not, I will just press forward. So I haven't given a talk like this before. I'm trying to do something without a lot of words on the slides to remind me. I was told I could kind of talk about whatever made sense to me. So there were a number of things that occurred to me, a number of approaches from out there that struck me as possible ways to go. I am kind of shooting for something like this. I'm not really going to talk about my science. I'm going to talk about a number of different things here. I'm not going to be talking about my time as a SSERVI PI. So as I said, I'm shooting for something like this. It's possible, or maybe even likely that it's going to end up being more like this. But so we'll see how it goes. Um, so I'm a planetary astronomer. I get my data, most of my data, at least for most of my career, by going to the telescope. I've used all of these telescopes in this picture. The one at the bottom middle there is Wallace Observatory's telescope. That was the observatory at MIT that I was able to use as an undergraduate. I get most of my data for most of the papers I've written at the NASA Infrared Telescope Facility, the RTF on Mauna Kea, in the upper left. The MMT there is in the bottom left in its actual multiple mirror configuration originally, and the most recent paper I've written uses JWST. So my I've always loved observing. I had a telescope when I was a kid. And being an astronomer, I think has helped me to kind of have some perspective and accept things over which we have little control, like the weather. It's kind of, again, I think helped me have some sort of perspective to try to focus on, okay, here are the things that I can control to try to optimize what I'm doing. Here are the things that we just kind of have to prepare for as best we can and let them go. Um, and I guess in between, the bottom middle there and the top right, um, I've seen that planetary astronomy is not necessarily seen as an ongoing vibrant field that it is. I won't name names, but I was told by a Mars researcher about 25 years ago when I asked him, I said, I'm about to graduate with a PhD. Mars is an ongoing thing. What can we do in the planetary astronomy field to help advance Mars science and Mars exploration using telescopes? And this person said, nothing. There's nothing you can do. Go do other things. We don't need you. Um, I think since then, this person has been proven rather wrong. Again, Jen Heldman in the room, certainly through LCROSS and ground-based telescopes participated in that. And one of the two early career winners, Casey Hannibal, has also been using telescopes to learn important things about the moon. And of course, the DART mission used telescopes heavily as a critical part. So I think there is a bright future for leveraging astronomy and astronomical assets and people who use them for planetary science and exploration as a whole, if we're open to it. There's a bit more I could talk about there in terms of keeping facilities open. JWST in the upper right is an amazing facility that is very capable and takes a lot of resources. And unfortunately, the resources, because we seem to be in a resource limited environment, sometimes we are left choosing between, supporting some things like JWST at the expense of things like the RTF. Really, we need both. So one of my first major papers, really as a first author, outside of being a postdoc and all that, was finding ice and organic materials on the surface of the asteroid Themis. And I was in Houston at the time for a meeting, for a conference, and when the paper came out, and I went to the Houston NPR station to give a interview, which was I took that picture on the right there while I was sitting there. And as I was driving to the radio station, I thought, this is great. This is wonderful. This is really, the sort of thing that that you hope for. And then it also immediately struck me that this isn't going to last. This is not how life is going to be the whole time. But that I need to remember in the bad times that those also pass, to kind of hold on to this feeling that things are good, and knowing that good things also pass, to try to remember that bad things also pass. It's been easier to remember when good times are happening that they will pass, than to draw back the good times when the bad times are happening. But it is something that I've tried to do. And at about this time, I also started to realize that Ceres, the asteroid Ceres, was about to be a hot topic. The Dawn mission was going to be heading there. I had a long-standing interest in Ceres. On the left there are photographic plates of Ceres that I took as a sophomore in a lab class. And so I began writing a bunch of papers about Ceres, figuring that I wanted to position myself to be the expert. So when Dawn got there, I would be able to be heavily involved, and wrote a bunch of papers. As happens, um, the papers weren't always right, but I always tried to say that if a paper wasn't going to be right, I might as well be the one to try to show that I was wrong. Um, and of course, this is also, I should note, this is where the link with Angioletta Coradini is for me, since she was, of course, involved with Dawn. I don't think we ever met, but this is the link here. Um, so that's what I was shooting for. Best laid plans. I applied to be a guest investigator on Dawn for both Vesta and Ceres, and neither one was taken. And in fact, I was 0 for 6 or 7 in terms of participating scientist proposals, with a bunch of other ones up there for basically anything heading toward any asteroid. I was not successful in these proposals, and kind of was in a little bit of felt a vicious cycle where I was involved as a postdoc with Deep Space One, the flyby of Braille, but that was kind of a one-off, and then I was a collaborator on New Horizons a little bit after this. So I had a whole bunch of time now available that I was not going to be spending, on Vesta and Ceres observations, and so tried to think about what else I might do. And at this point, I will say that things obviously seem to have worked out. Whether or not they worked out for the best, I think the piece of generalizable and unsolicited advice I might give is that things don't necessarily always work out for the best, but they do often work out in ways that you never would suspect. So, in a late 2011, a group of us at APL got together to think about mission proposals, and thinking about asteroid tours. And Rachel Klima and Carolyn Ernst and Nancy Chabot and I were working on something that we ended up calling Mantis by January 12. That was the name. So Mantis was a discovery proposal. The four of us, and Brett Denevi was heavily involved. We're kind of the main people putting this proposal together at APL. I was the PI, and I really learned a ton while I was a PI on this proposal. I'd again never really been involved in a proposal in a mission. And being at APL meant that I got to work closely with engineers. I got to work closely with managers and cost analysts. And that latter one in particular was interesting because I think prior to this proposal, I would have imagined, okay, well, you're costing a mission. You go and you say, we need 75,000 washers. Washers cost 35 cents a piece at Home Depot. You put that number in. But, cost analysts have their own methodologies. They have their own publications. They have their own conferences. It is a field of study that is, got as much rigor as they can put into it, and involves highly trained professionals. So, they were valued members of this proposal team. Barbara Cohen was the deputy PI on this proposal. Olivier Barnouin was the project scientist. Maybe you can see if you can read close enough, although it's a bit small because I didn't intend this. Here's the tour down here in the lower left. The first time we proposed, we would in fact be in the middle of this tour right now, in the middle of this mission right now. We've been selected in 2015. Obviously we were not. We put in a great proposal. We were put in category 1. Um, I was very worried because it was a first time proposal. I was worried I was going to be a weakness. I was worried I was going to let the team down. There were 5 Cat 1 proposals that received funding in 2015. There were 7 Cat 1 proposals in total, and 2 of them did not get funding. We proposed again in 2019. Again, we were category 1. Again, um, we were one of 2 or 3 Cat 1 proposals that did not get funding. Um, and this was, came out just before the pandemic started, so not great times here. Um, and obviously, we were very, very disappointed, but we did try to keep perspective. After that first time we were not selected, we kind of had this attitude that kind of like with the weather and the observing, making your happiness contingent on things that are out of your control, or making it contingent on the actions of others, is really just a recipe for unhappiness. So the experience as a whole, even though it was unsuccessful, it did give a lot of experience and a lot of confidence for me and the group of folks I was working with, I think, to kind of be able to move forward with other things. And that then leads into Dart. Um, uh, Dart was kind of being developed originally at about the same time. It was led by Andy Cheng at first, and then I got involved along with a bunch of other folks. It was a spectacular success. I could spend, hours and hours talking about it instead of the short shrift I'm going to have to give it here. It was very very, very, it definitely struck a chord with the public as a whole, and pop culture wise. So I had the opportunity to share the leadership of the mission, to bring in several Mantis folks. It was just this amazing science and personal thrill. And a big part of this was this wonderful, amazing international team who worked really well together and pulled toward a common goal. Again, planetary astronomy was a critical piece of this mission. And a shout out to the Italian Space Agency, who contributed a CubeSat that was a critical piece of the mission, and that was put together in part, thanks to a SSERVI meeting where people were able to get together from the different space agencies and realize that there were multiple pieces that could fit together really well. Um, I want to talk about some individuals here. All the folks on this, most of the folks on this slide are people I've worked with. I was an undergraduate who did research with Jim Elliott there on the top right. Bob Brown there, Central Middle, was my postdoc advisor at LPL. Larry Lebowski was my PhD advisor. I'm going to talk more about him in a moment. Andy Cheng hired me at APL. Rick Binzel, I worked with when I was at MIT as a research scientist. Joe Vaverka, I never worked for, but he was the PI of the first mission proposal I ever worked on, and was very gracious with his time, especially for a newbie like me. And then I've known Heidi Hamill for a very long time. She brought me onto her JWST project. She also has been very generous with her time through the years. I'll point out for Larry that he also got involved in science education right around the time I was starting to work for him. So he exposed me to science education very early, and I know we're going to be talking about that next. So he definitely helped me think about science in a larger way outside of its academic box. I also want to specifically call out 3 people who I particularly want to recognize. Amanda Bosch there on the left probably was really my first science mentor. She was my undergraduate research advisor. We worked together on various projects. She taught me a lot about what it means to be a scientist without me realizing it. And she also may be the kindest person that I know. Christina Thomas there in the middle. She came to MIT when I was back there as a research scientist. She was my Padawan. She's now full-fledged Jedi. And it's just been very rewarding to see her career evolve from being, a prospective grad student all the way to being a tenured professor. She was in charge of the observing team on DART did an amazing job. And I look forward to many future projects with her. And then, of course, there on the right is Nancy Chabot, my partner in, depending on who you are, either crime or partner in justice. We met in graduate school, so we basically grew up together. We don't always agree on everything, but we do take each other seriously, unless we're being goofy, which is often actually. And she's really taught me a lot about effective ways to kind of do good and to navigate difficult situations. She got her PhD 2 years ago. 2 years ago, she got her PhD 2 years after me, and we were texting yesterday whether she might still be eligible for the Early Career Award. So you should consider that. I was at LPL as a graduate student. I'm just going to flash through these, but I will, of course, point out Jay Greer, my spouse, who has been there, every step of the way, and a massive part of every aspect of my life for the last 30 years. APL has been a great place to work. I've been there almost 20 years. I wouldn't have had the opportunities I've had if I'd been elsewhere, or they would have been even bigger challenges. I've again learned a lot from the people there. Whether or not we're close friends or even would call each other friends, I've learned a ton. And then the asteroid community at large, beyond where I've worked, it's just full of wonderful people. That doesn't mean that it's not without drama or angst. And in a lot of ways, the folks I've been showing on these slides, really are family in a lot of ways. We grew up together. A lot of us met each other in our teens or our 20s. So these meetings serve as reunions, and these relationships evolve with time, just as those in legal families do, with these real and deep feelings. So in that spirit, I just want to take a moment to mention Betty Parazzo, who was a friend and colleague. I suspect many of you know her or knew her. She has had a lot of honors bestowed on her. Now their school's named after her in Italy, craters and an asteroid. I very much wish she were here. I suspect she would have won this prize herself by now. I also want to call out someone who maybe fewer of you know, Stephanie Lawson. She passed away in November of 2022 of a chronic illness. She was part of the lunar community. We met in college and were friends there. She got her PhD from the University of Colorado. She worked on Clementine data. She left the field, but we remained in touch. She got me a Mantis Funko Pop figure when we proposed that mission. So I just wanted to say that I miss her. I'm sure I'm running low or out of time, so I'm going to skip over the George Harrison. You'll have to ask me about George Harrison. And I'm just going to say that this is a tough time to be in planetary science, among many other things. Of course, it's not uniquely difficult by any means, but it does take a toll on mental health. This paper came out recently from Nature, talking about mental health in planetary science and planetary scientists versus career path or career stage. I cannot imagine what it would be like to be an early career scientist right now. There's just a lot to navigate in the world at large, trying to establish yourself, trying to deal with just massive uncertainty. I don't think it's easy to realize the stresses on being middle-aged until one is there. And a lot of things that we hope do not get visited on younger folks. We have to take care of our parents, or potentially we are losing them. There's just kind of day-to-day logistics and maintenance things that I don't think you really realize until you're there. And trying to prepare for the future and protect those who care. So really just this is kind of a plea for us to try to understand each other, to try to give each other room to try to understand each other and treat each other with as much kindness as we can work up. And with that, I'll also plug this workshop by Jay Greer and Julie Rathbun, who are looking at EDIA and looking at it through a lens of empathy and again, trying to be empathetic to one another. So in either my last couple minutes or after my last couple of moments, I want to think about or bring up, the future of planetary science. We had this Vision 2050 meeting a few years ago, but that was largely focused on things like, which particular widgets do we want to develop, which particular planetary body do we think we should go to, and I think there are some very big issues that are unaddressed. And maybe I've picked some funny ways to think about it, but I'm thinking in particular about Sigourney Weaver up there on the Nostromo. What will it mean to be a planetary scientist when commercial entities really are taking a major or a leading role in space exploration and maybe have other things that they're trying to get done? Um, what do we want planetary science to look like? What do we want a planetary science career to look like? Do we think that it should be a career, or is it just a stage that you go into and out of, but you should not expect to be doing your whole career? I have my own personal opinions. I know what some budgets make it look like. I think these are the sorts of things that we should, as a community, try and tackle. And this is going to be my last point here. I mean, we are scientists. We are trained to take limited data and to make consistent narratives out of them. We have interests and priorities as a United States community of scientists and as a larger world community. And those interests and priorities may not always coincide with those of our space agency or other space agencies or the institutions we work for. And it's, I think, important for us to keep that perspective, and that we don't let timidity and laziness keep the interests of the science community from being heard. So we should use the leverage both on this large scale and as individuals. I think use the leverage and the opportunities we have to do the things we believe in. That if we treat our time as having no value, then others are going to do the same. So with that, thank you again for having me, and I hope you have a good rest of your day there in St. Louis, and I hope to see you all in person sometime soon. Thank you.
Thank you, Andy. Thank you so much.